Hello and welcome. What I have in front of me is a terrestrial laser scanner, one of the high-end laser scanners available. This thing works a little bit differently to your typical total station. So a total station works by turning an angle and measuring a distance. What this thing does is the same thing, turns an angle and measures a distance to a surface, not the prism or target that you're aiming at, and it does this a lot and very quickly. So this scanner can measure about 2 million points per second, and basically what it does is measures and spins. It's got two spinning parts on it, this one here as well as the piece in here that spins around, and together does a 360 around the room and measures everything it can see. So it'll measure millions and millions of points all around its environment, and from that one setup it can create and model this whole environment. And basically what that does is when you bring it onto a computer, it's got millions and millions of points from this one setup that all come together to bring the term of what we call a point cloud. So this thing is creating a point cloud with every setup that it does. So what you are then able to do is scan one spot and then move it to another position, repeat the same process, so then you have two scans, and you can then merge those two scans to fit together, and that process is what we call a registration. You can register these two scans together to fit into the one environment or be relative to each other. So you're basically just creating a point cloud at every setup, merging the point clouds together and creating one big large data set or one large point cloud for your job. Of course, there are other laser scanners that you can use. It doesn't have to be this one. This one is quite a high spec, high accuracy laser scanner. This is definitely a survey grade laser scanner. There are more entry level scanners available, including from Leica's range. They have different models as well, and each of them have their own benefits. This one particularly is beneficial for those high accuracy projects. So if you're getting tolerances that are really tight, for example, if you need to model a factory where there might be pipes and hoses and machinery that needs to be replaced, then there's no question about it, you need high accuracy, and that's where this one comes useful or becomes really handy. There are lower spec ones which their benefits are you're compromising a little bit on the accuracy, but you're often gaining things like speed and the speed of how you can register this point cloud. So Leica's lower down spec laser scanner is an RTC 360, and what that one can do is scan as this one can. You'll do a scan in one position, and then this thing will take about 10 to 15 minutes to do the scan, whereas the RTC 360 can complete the same scan in half the time, even less. It is a lot quicker with its scanning time and taking photos. The things about this scanner is this thing can do a self-registration in the field by, on the screen here, you can coordinate targets which are on site. So targets often can look like this. Different companies have different types of targets. They can be spheres as well, which definitely aren't the preference. This is the better one. You have targets and they are a magnetic base on them, and what you can do is stick them on metal surfaces. They'll stick up, and scan them and coordinate them on the screen here. So you can give this an ID number. It will then link up these targets to their position in the field. So what you need for this one is a minimum of 2 targets which have coordinates. So what you need to do set the target up somewhere on site, it stays there basically all day, or as long as you can see the scan targets with the scanner. You need to coordinate the center point of this target with a total station, so you can give it an XYZ value, which might be relative to your survey control on site if you've got that established already, or maybe you're creating that yourself. And once that XYZ value is known, you can then apply it to the scanner here. So you're giving that the same target ID as well as wherever the other scan target is. Minimum 2, definitely recommend more than 2. The more targets you have, the better the registration, so the better the quality of the merging of your point cloud data you can get. So we have 4 targets for this. Often what you can do is, if you really need a really high accuracy output, you can measure these targets, and then once you're scanning, or you know you're not coming back to these targets, you can pull them off and then put them in another position and then re-coordinate them. So you're basically bringing through that high quality survey control network into the scanner, so you're ensuring that you're getting high quality registrations and high accuracy registrations. So yeah, you coordinate it on the scanner. Minimum 2, we have 4, which we move around as well as if the site's larger and we need more positions. And then basically merge all of these targets, give them the ID, and then it creates a registration and links all the scans together. So talking about a registration and how you link these scans, there are 2 options. What you can do is a target-based registration, or you can do cloud-to-cloud registration. The difference between the 2, you're giving a target ID. For this one, the lower spec ones, you can also measure targets as well, but you can't do it in the field. So you can still do a target-based registration, but not in the field. And what you do with the 2 options, so target-based we just went through, then you've got cloud-to-cloud. So what it does is registers your point clouds based on overlapping points. So it ignores the targets. You have one scan here, you have another scan which might be just on the other side of the room here. They all have common features, which could be these walls, as well as vertically the roof and the floor, or tables or anything in the room. And what you can then do is get the 2 point clouds side by side, rotate them to be in the same orientation, and then fit them onto each other. So cloud to cloud, as it suggests, you're getting one cloud with another cloud, so one scan with another scan, fitting them together and aligning them based on the 2 clouds and common features. So this is often a good way to get a cloud registration together, and you can get it pretty accurate. The target-based is definitely recommended for 2 things: coordinating your point cloud onto a survey control datum, or for those high accuracy registrations. So because you're coordinating that single point, it is a high accuracy way of registering your point cloud together. So 2 output options: you can have a point cloud on a survey datum or a specific datum of your choice, which is using these targets to tell you where the XYZ values are based on your survey control. Or you can do an arbitrary point cloud output, which is you merge the point clouds together and you don't really care where the XYZ values of all these points are, so it's just a raw output of just the point clouds linked together. So the best way for a cloud-to-cloud registration to work is what you need to think about is making sure that each scan or a scan has a high amount of overlap with a previous scan, because obviously what you need to do is find common points between the 2 scans so you can sit them on and link them with each other. So it's almost what you can do in the field. It's kind of like a leapfrog situation where You have one scan and you're basically just hopping your way through each of the rooms, making sure you've got a good link between each of those scans. And then when you're in the office and you're doing the cloud-to-cloud registration, the important thing then is to know where those links are. So when you're going through your software, you can often link one scan with the next. Sometimes you can't do that continuous chain of one after the next after the next. Maybe you can go, you complete scan 1 and then you go scan 2, which can be in the same room, scan 3 into the next room, and then scan 4 might be in another separate room. So maybe you have to link scan 2 with scan 4 and scan 2 with scan 3. So you can do a cloud-to-cloud registration with 2 and 3 and a cloud-to-cloud registration with 2 and 4. The best way to get high accuracy cloud-to-cloud registrations and ensuring that your registrations are on datum and correct with good overlap is trying to get more than one link for every scan. So in that scenario, I had a link between 2 and 3 and 2 and 4. If you can, you try and link them up in as many spots as possible. So 3 and 4 have one link with them. Maybe there's a window in between scans 3 and 4 where you can link them up together. So you essentially create a closed loop of links and strengthening your registration, because if there are a little bit of mismatches between each scan, the registration is able to then pick that up, and you can then either refine it or improve the registration or help verify that your registration is on the correct datum and correctly linked with each other. So the more links you have, the better. And basically what you have as an end result with your cloud-to-cloud registration is a large web of links between all of these scans. One link between a scan is good and you can get a result, but it doesn't often verify or improve or have a good accuracy output as a point cloud. So you might have, if you've got a poor registration, when you're linking two clouds together which have common features, they might have a slight twist in it. And then what that looks like is when you're viewing the point cloud, it almost appears as if there could be two walls or two ceilings. There's just a little bit of difference between one scan from the other. So you need to make sure you spot that in the registration and fix that before you create this single point cloud file, where it can be a lot harder to tell where the error is, and then going back to fix it, you have to go back to the registration and apply those corrections. Point clouds are an incredible output. What they can do is create a 3D environment for many different uses for people to use. So some things that we can do point cloud outputs for is for CAD modeling. Maybe that's for BIM modeling as well, creating 3D environments for designers, or maybe it's for PDF plans and 2D views of features. There are quite a lot of different options you can do with point clouds because it's a 3D model of your environment. It's a really huge range of options you can do as far as outputs, and sometimes the best part is you can use your creativity and imagination to produce an output that might best suit what its needs are for the end result. So sometimes it's not just a point cloud that we're creating and sending out to clients. Sometimes we need to go that extra step further, which might be modeling in 2D, modeling in 3D. There might even be simple things like creating fly-through videos of the environment, just to give a perspective of what this point cloud looks like, and sending it to people who can't actually use this software or don't have the ability to view and analyze this software, just to see it in simple terms of what it actually looks like and how incredible it actually is, and just the quality that you can get from a point cloud. So this technology is changing quite a lot, but it's been around for quite a while now, particularly terrestrial laser scanners. And those who have been in the industry for a long time really valued people with the evolution of this technology as it improves. Someone who has really helped me on my journey and training to be able to use terrestrial laser scanners as well as mobile laser scanners is someone that I've worked with for a while. That's Matt Travaskis. He's quite an expert in this field and has been doing it for a very long time now. I think he's got that reputation within the industry of being one of the leaders in this technology, and yeah, it's great to have been taught by such an expert in this field and an understanding of how all this technology works, and as it does change, to stay on top of it and make sure we're keeping up with all of these changes as it does improve. So if you do have any questions about terrestrial laser scanners or want to get some advice on the scanners themselves, please don't hesitate to send through a message, and if you have any questions about this video, please send through a comment and I'll be sure to help. So thanks for tuning in, and we'll see you on the next video.